All right, part two coming at you. We're going to pick up with part two of solving rational equations, where we're going to briefly, because the next lesson kind of really validates or solidifies our ability to solve rational equations, but look at what this idea of an extraneous solution means. So, algebraically, there are instances when we come across numerical values that validate an equation. Typically, we see this with rational functions because they have more restrictions with their overall structure. Um, but back to the original point, this numerical value, while it does successfully solve the problem for whatever reason, maybe the context, maybe the type of function that we have, because there's other functions that have restrictions like rational functions, we would say that the value is an extraneous solution because, yes, it works, but we can't count it because it don't work because it breaks the function. So we don't want to do that. But without any further ado, let's pop in. So here in our warm-up, you have four different equations. Just kind of walk through them mentally. No need to actually write down any type of answers. Just interested in starting some conversation amongst you and your peers about different strategies and approaches that you use to solve these. There's a pretty common one that you'll probably reference from your time eons ago when dinosaurs roamed the earth and you learned how to solve these type of proportions. As promised, with that first lesson in the week being so front loaded, this will be the only activity for this lesson. So I told you, make good on my word. But Noah's out there going on a boat ride along a river with his family. In still water, the boat travels roughly 8 kilometers per hour. In the river, it takes them the same amount of time t to go upstream 5 kilometers as it does to travel downstream 10 kilometers. If you're not familiar with what those words mean, if you are traveling upstream, that means you are going against the speed of the river or the water. Okay, so it's almost like it's windy and the wind is pushing back against you, the water is pushing back against your boat. So there's some resistance. However, if you're going downstream, okay, downstream allows you to use the power of the water to propel your boat quicker, with less strain, I guess, on your own body or your own boat. So first and foremost, write two expressions for the time it's going to travel. It take to travel 5 and 10 kilometers. Keep trying to say kilometers. Um, Remember, as we had mentioned a few lessons ago, if you want to calculate time, this goes back to physics. Time is equivalent to the distance, so that'd be 5 divided by the rate. Um, do not assume that the denominator simply can be r, because of these contextual words of upstream and downstream. So when you do determine whatever your expressions are, I would like for you to calculate the actual speed of the river using the expressions that you were able to generate. Um, and that is where we will ultimately conclude for today, because tomorrow's lesson, or activities, I should say, will really hammer home our ability to solve rational functions.